Um, Hello everyone. I'm Joel. I think we'll skip the self intros. Yep. So today we're going to do a Go tutorial. Um, there's a GitHub repository that contains all the material I'm going to cover today, and it's under the Apache 2 license. So feel free to go wild. Um, So yeah, I'm gonna start. Any questions before I start? Because actually, we did this tutorial last week with the same people on the call today. Um, so if anyone has any questions, feel free to interrupt anytime. Okay, so I'm gonna get into it. So um, Golang. Let me start with a summary of what Golang is. I'm just gonna go over it one more time. Golang is a typed language that compiles to a binary. It was designed by Google to run basically on the back-end REST API services. Um, on top of REST API, Google has also come out with something called gRPC, which works together with something called protobufs. If you look those two things up, they work over not like normal HTTP, which is WebSockets and REST API, but HTTP2, which gives you um, basically duplexing connections, binary payloads. It's really convenient. So I recommend looking up gRPC and protobufs and learning that in parallel to learning Go, because Go and gRPC go together like pizza and beer, cheese and sausage. Okay, um, so what makes Go special? Besides the gRPC thing I mentioned, I'd say what makes Go special is, besides being typed, it really simplifies concurrency programming by using something called channels. I think traditionally, when someone wants to program something that's concurrency safe, um, it's the tooling in the languages like C, C++. It's just really awkward. You got to use stuff like mutexes and to try to get atomic locks on different bits of data that you're modifying from different programming threads. Oh yeah, by the way, just a quick review. So for concurrency programming, what that means is the computer is executing a program, a set of instructions, and there's multiple instructions being executed simultaneously. And if in programming generally we're talking about threading. Forking is something else. I'll just drop the word fork and you can Google what that means. But that's a little bit separate. But for programming, most people are talking about threading. And threading is multiple sets of instructions that all execute in parallel. But the memory is shared. So you're going to have a situation where two threads, basically two uh, instances of execution, try to modify the same piece of data. Um, and doing that is quite dangerous because, well, I mean, you can't predict what's going to happen. It's kind of like random what happens to that piece of data. Your program will probably blow up. So concurrency programming is quite difficult because when you have threads and you're trying to deal with concurrency, um, like mentally, it's difficult to lay out multi-threaded programs in your head. If you're coming from Python, right? Python is like a kind of single thread. I think Python might have threads, but basically, most people when they program Python, and feel free to correct me if I'm wrong for the Python experienced people here. It's basically a single thread. You have a single line of instructions. So when you look at the code, it's easy to debug. If you're coming from TypeScript and JavaScript, that's like callbacks, right? Because JavaScript is for the web browser. Web browser deals with events. So, oh, by the way, a callback is when you have a function and you treat it as a variable, and you put the callback into an event loop, which you can think of as like a while loop. But the top of the while loop is basically you're listening for events to come in. When events come in, you find a callback that corresponds to the event. So, for example, if someone clicks on a button on a web page, you go find a callback that corresponds to that button, and then you like run that function. And inside that function, it's kind of like Python. It's like a sequential set of instructions, and you just run it. But JavaScript is really like single threaded, but all callbacks. So it's all event based. So that's also kind of mentally difficult to grope. So I would say Python's probably the easiest to read, and JavaScript's kind of like really difficult for me personally to debug or to grope. Golang is basically taking uh, well, callback programming is not concurrency based, but Golang is just basically you can do event based stuff in Golang, but not you don't have to use callbacks. You get the same readability as Python, but it's concurrency safe. So okay, that's long summary. Any questions so far? I'm not sure how many people on the call like generally do multi-threaded programming. I have not. I have avoided it for as long as I could. Just Golang makes it easy. So, um, no questions? No, it's very silent. Cool. Okay, so basic syntax, just basically kind of like C. You have data types like integers, unsigned integers. You have strings. You have byte arrays. Um, this colon equal sign. This is how you instantiate the variable x and assign it at the same time. You can just create a variable by declaring it here and then assign it later. Um, you have conditional statements. The conditional statements don't have parentheses, so I mean, slight difference from other languages. Um, Going on to like how to store data inside Golang. So again, it's like C. You use structs, and I'd say the important thing in Golang is learning the difference between pass by value and pass by reference. So if you have a struct, there's two different ways to use struct inside of Go. The first one is pass by value. I'll explain the difference between pass by value and pass by reference in a second. Let me just go through the syntax first. This is pass by value. If you go to pass by reference, there's two different ways to. Well, this is one way to do pass by reference. You just use this new pragma. And also, if you have a reference, the reference can be equal to nil, which is nothing, empty. So the difference between pass by value and pass by reference is when you throw around the variable. In this case, we have a variable apple, which is a fruit. When you toss this variable around a program, like what are you tossing around? Are you tossing around a copy of the struct data? Or are you copying essentially what's a pointer, a reference, right? Are you copying a reference to the data? In fact, there's just like one instance of the data, and then like Apple points to it. The implications are important, and we'll see the implications by going to a function example. And by the way, everyone's okay so far? Okay.
Yep.
Yeah.
Yep.
So just quickly going back, in JavaScript, like everything's passed by reference because it's single threaded, and so you don't have to care about what we'll see later, which is like protecting how data is modified inside your data structures. In JavaScript, you don't have to care, single threaded, so basically everything's passed by reference. Um, okay, so let me go down to the functions. This is how you declare a function. Just func, name of the function. You put your arguments here. Um, I think in other languages, there's usually like a colon between the name of the variable and what type of variable it is. Um, but in Golang, there's no delimiter here. It's just a space. And and you can have multiple arguments. You just put a comma here. You can also return multiple items. In this case, we just return a bool. But if you put a parentheses and a comma delimiter, you could return multiple variables. Um, so let me show you the difference between pass by value and pass by reference for function calls. Um, so for this function is getting passed by value. And then, so the difference, finally, the difference between pass by value and pass by reference is I am copying this data when I use it inside the function, which means I can't modify this data. It's kind of like read only inside this function, since I'm dealing with a copy of the argument, not the actual data. But if I use pass by reference, if I use this function call and I just put an asterisk in front of the struct name, I'm getting a reference to the data instance, which means I can modify the data inside the struct. So as you can see, I added a little data member that's basically the state of the fruit. Has it been eaten or not? If I want to mark is eaten as true, as in like I ate the fruit, then I need to pass by reference using this function call. Um, and Go, so this is separate syntax only, not dealing with pass by reference versus pass by value. So you can add function calls as kind of like a trait of a struct. I think it's called a method. To do that, you just put the name of the struct, just a variable with a struct here. Then the function name, and then the arguments here. I just have no arguments, and then what the method returns. Um, in this example, I have passed by reference for the struct method name, but I could just take out this asterisk and then just have a method that works on the a copy of the data. So like this style. If I remove the asterisk. Okay. Any questions so far? Okay. We'll get to the doing part later, so you actually get to test this out. One more thing. Let me summarize basically what um, I guess your modus operandi, your mo here. Um, and Go. The default choice is to copy data. You don't want to mess with references because if you mess, as soon as you touch references, then you have to deal with concurrency problems. So by default, you should go for pass by value. Just copy the data. Um, but sometimes you need to store the state. So if I have a fruit and I want to know if it's been eaten or not, I need to keep the state. So anytime you need to keep the state, pass by reference, which means you need this asterisk. So, yep. All right. So any questions about pass by value, but pass by reference? No. Okay. So I'm going to introduce my go-to programming pattern. Um, and this is what I use because it's just mentally easy to get. There's other programming styles, but for me, as I said, the MO is use pass by value for everything as much as possible, and then pass by reference only if in a very specific case that you need to store some state. Um, but then, like if you have to store state, which means you have to use pass by reference, then how do you protect the reference thing from being clobbered by like 10 different threads, like all trying to change uh, the same data point? Um, and the way I do that is use something called a go routine. So a go routine in Go roughly corresponds to what a thread is. I'm assuming everybody on the call knows what a thread is. If you don't, I mean, it's just essentially it's a sequential execution of some instructions that's independent from another execution of another set of instructions, but it's happening in the same memory space. So everybody can see everybody's data, um, but the instructions are different. Um, in Go, we use Go routines. Go routines, as I said, corresponds to threads. However, it's technically not a thread. It's part of something called a Go runtime. Uh, but for, I mean, for the first introduction into Go, it's a bit out of scope to go into the specifics of what a Go routine is, other than it's basically like a thread, a pseudo thread. Um, so, how do you spawn a Go routine? You just use this Go thing, and you place it in front of a function call. In this case, I have a fruit, um, and I call this function eat fruit, which means I'm going to take the fruit and set the is eaten bool to true because I'm eating the fruit. Um, this call is safe. So let me get to safety here. This call is safe, though it doesn't have any meaning because if I make changes to the fruit state here using a copy of the data, like the, it's not going to stick because I'm just dealing with copies of the data, not shared state. So this is safe, but this is not how you want to deal with shared state. Um, so I can make this function call, in which case I'm keeping the state. I'm using a reference, but I'm using Go. I'm spawning a Go routine. And the problem here is now I have two Go routines. So I have the Go routine I'm already in, and then I have a new Go routine that's changing the state. And so I have two Go routines, you know, with the ability to modify the same state. So as I said before, this ends up, clobbering the same data. So this is not really safe to do. Um, any questions so far? We'll see examples pretty soon. All right, let me just actually, I think at this point, let me cut it off here and let me move to the Visual Studio Code. Otherwise, we're just going to get swamped with um, vernacular and lingo. Okay. I am trying to share my Visual Studios screen, so please stand by. There's no questions, comments, anything that's not clear? No. Okay. Um, all right, well, this is some other code. All right, so hi. This is a Go program. If you go to the README and the repo, it'll tell you how to create your own Go program. And when you create a project using Go, well, what you're essentially doing is creating a module. So you run this command, go mod init, and then the name of your module, which is basically the URL for your repository. Go really works well with open source code, but if it's private source code, then this URL thing gets a little tricky. And your dependencies will also have the same naming style, which lets you pull in dependencies just by the URL of the Git repository. When you run this go mod init, you get a go.mod, which basically lists out your dependencies. I don't have any dependencies besides the core modules here, so, or I should say core packages. It's kind of weird. So, like, I'm creating a module, but I download packages. Oh, okay. Sorry. Now I heard. I remember now. Um, Module contains multiple packages. Um, that's what it was. So in the base directory, I created a main.go file, which is in the main package. The main package is the thing that when you create the binary, this is this is what's run. So if I do go build, can everybody see the terminal? Is it too small?
I can see it.
I can see it.
All right, should be able to see it more now. So I did go build dot. I do ls. The name of the binary that comes out is the name of the module, which is Go Tutorial 1. Oh, I have a server here. Oh. In which case, I wrote a server here. So this main function is what runs here. If you want to get arguments in here, you would use the OS package in OS module, and then you can access this array string and get access to the arguments that come in on the command line. Which actually could show an example. So if I just need to make sure the length is need one argument. Actually, a shortcut for building is just to go run. Okay. That did not do what I expected. Oh. All right, panics. Okay, that's what I was expecting. Okay. If I want to add argument here, I would do this. And you can see the argument shows up here. Okay, so before I go into all of this, which is what I did last time, I'm going to go through the Go tests and we can see kind of individual properties of Go that we talked about earlier. By the way, to do a test, you just take the package name and then you put an underscore and you just write test. And then to write a test function, you write a test with capital letters, starting with capital T, and have the argument like this, testing.t. And this is how you run a test. And if you use VS Code and the Go plugins, you get this cool thing where you can just hit this button and it'll automatically run a test for you. Or you can run debug. You can put breakpoints in here. Oh yeah, here. So I showed you how to initialize a variable. You can use the colon and equal to create the variable and set the initial value. You could declare the variable, not set the initial value. That's dangerous to do in Go because in Go, Go will make assumptions about the default value of the variable. So here we don't assign an initial value to A. But if we look in a debug, Go assigns 0 to the value A. So that's why we end up with a C equal to 3. But if I uncomment this, it will work. It'll pass. And a test, if you want to fail the test, you just put this fatal. I put fatal F here. The F just means I want to put some variable inside the string here. It's the same with this. This is print here, but up here I have printf because I'm putting a variable into the string. Okay, so any questions so far? No questions. So it's either, is it too difficult, too easy, too slow, too fast?
Sorry, I don't understand the difference between A equals 1 and B semicolon equals 2.
Yeah, so these two lines together is the same as A equals 1.
Okay. So Go understands that 1 is an integer, not a string?
Good question. So it guesses that it's a 1. So actually the real anal answer is this one.
Okay.
That's a good point. This comes up a lot in my coding. I might need a unsigned integer, in which case I have to go like that.
Okay. Okay, got it.
Curious, what happens if I do this? Yeah, it doesn't compile. All right, that's what I thought. Which means my Go thing is not parsing errors correctly. But yeah, this compiles. Thanks for the question. Anything else?
I'm good.
Miguel, no questions? Silence. Okay. All right. So let me talk about server. So for server, I mean, what do we want to do for a server? So server, there's a client. The client talks to the server, does something, sends a message to the server. The server takes the message, does some computation, and returns an answer. The computation part, I mean, if you're lucky, you don't have to track any state. But if you're unlucky, then you need to track state. So I wrote an example of a server. So I have a package called server. And this is like, to me, the simplest server I could think of that has state in it. Let me go to my README and let me explain my default programming style template for my server. So we're going to need to take the state and put it in a special Go routine. So in this case, I'm going to have a state. It's going to be called fruit. Actually, do I have fruit here? I have configuration. Okay. But here in the example, I have fruit as the state I'm setting as the initial state. And so I take this function, I create a Go routine that contains this initial state. And so this Go routine alone will control access to the state. But if the state is inside this Go routine, how do other Go routines get access to this state? And so for the access, I have channel. I have not talked about channels actually. So let me go to the channel test. And please put that server discussion on pause because now we need to talk about how Go routines talk to each other. How much time do we have? We got about 14 minutes left. So maybe I'll probably just finish with the channel thing today and do the servers next time. So to do the server properly, we put the state inside a Go routine. But now, when you talk to the server, you're not talking. You're talking. The talking is coming from an external Go routine, and now I have two Go routines, one outside and one inside, and I have to have them talk to each other to make the server work. To do that, Go routines use channels to talk to each other. So I have an example here of a well, this is the example of function call here. So A, B, C equals add my numbers. Add numbers, A and B, A plus B, I return an integer, right? So I get C. So this part's, I think, easy to understand. Um, so here I'm going to use a channel. I create a channel using the make and I guess another way to say this is another way to declare a channel by using the var. In either case, you're using chan to mean channel. And the channel basically it's a queue. So you have a queue of stuff in it. And the stuff in it is defined when you create the channel. So in this case, I have a queue of integers. And you can put stuff into the queue, in which case you say you're writing to the channel. And then you can pop stuff out of the queue, in which case you're reading from the channel. So in this channel here, I can put integers into it and take integers out. But how big is the queue? You can make a queue that's got no elements in it, in which case you'll have blocking. And blocking is, let me get to blocking in a second, but by default, you should have a queue size greater than 0. So your program doesn't completely freeze. Now I'll show you an example of freeze blocking in a second. So we're going to use channels. So I need to spin off a Go routine using this function. So in this function call, I have the A and a B again. But instead of returning an integer like I did in this function, I'm going to return the answer via channel. You can see the difference. I declare a channel as an argument here, which is different than like up here, right? So this function is adding A and B, and it's going to return an answer. So that means I need a channel I can write to. So what this function is saying, like, it's saying, give me a channel that I can write to. And by putting the arrow here inside this function, it won't let me read. My VS Code was working correctly. This thing would have a bunch of red lines underneath because I'm specifying a channel I write to, and I'm trying to read, so this doesn't work. So it's kind of like a good type safety thing. So anyways, I add A and B together, and then I write the answer to this channel. And then up here, I just read from the channel, and I should have, I just get the result here. So actually, let's try it out. Let me hit debug, pass. All right. Let me show you what the channel looks like in debug. So if I go here, you can see this is what the channel looks like. So this Go routine, you can see the Go routines here. Let's see, if I'm really lucky, I can find the Go routine that's writing the answer. No, I am not lucky. Oh, wait. All right, not lucky. Anyways, sorry, I'm getting lost here. Okay, so anyways, I have two Go routines. This is the channel. You can see the channel has one data thing in it. Inside the buffer, we can take a look. The answer here is 3. So the number 3 is inside the channel. Why is there a number 3 inside the channel? Because I passed a 1 and a 2 here. Down here, I added the two numbers and I wrote it to the channel. And now here I'm reading from the channel. If I block here and move on to the next one, the channel is 0 because I read from it. So the buffer there's nothing in the buffer. Um, it should be 0, right? Yeah. So that's how the channel works between two Go routines. Let me show you what blocking is. So if I take out the 1 here, that means this channel has no buffer. There's the queue size is 0, which means the two Go routines have to kind of like sync with each other in order to pass the data. So it's going to block here until somebody reads, and this will block until somebody writes. So if I run test, it'll pass. However, can anybody tell me what happens if I read first and then spin off the Go routine? Anybody's can tell me what happens here? Any guesses?
Throw an error.
No guesses.
Panic.
Is it going to block or not block? Take your come on. Somebody take a chance here. Give me a wild guess. Block or not block?
Block.
Thanks. Thanks.
Panic.
Where's it going to block? Line 16 or line 15?
16.
Let's find out. Debug test. All right. What is this? What is this fatal error? I've never seen this before. Fatal error. Hey, I've never seen this before, so I learned something new today. I don't know if you guys can see that, but in my screen, the call stack Go has detected a deadlock. So it blocked at line 15, right? I mean, not right. The answer is line 15. It blocks because it's trying to read, but nobody's writing. The reason why nobody's writing is because the Go routine spins off after I tried to read, which of course it's impossible because I can't proceed unless somebody writes.
Wait, how do you know that it's being blocked on line 15? Like, where does it say that?
Shit. Oops. How do I know? Well, unfortunately, I would know for sure if I blocked somewhere. But you could tell by looking at the code that it's not going to get past here. Because there's no data to read, right? And it cannot skip. Okay. So line 15 is asking the channel, like, give me data. And channel ANSC is saying, I don't have any data. And then ANS is saying, well, I can't go to line 16 without an answer from you. And so that's how you know it's blocked at line 15.
Okay. This fatal error has nothing to do with that?
The fatal error is, so there's like the Go runtime tracks all the Go routines. And essentially there's two Go routines running right now that we care about. That's this function here and this function here. And between these two functions, you can tell from the code inspection that they're going to have a deadlock because this function is not called until it reads from this channel. But there's nobody writing to the channel until after it's read. So it's impossible for someone to write to the channel because there's no Go routine writing to this channel until after the read is complete. So the Go recognizes this, the runtime recognizes this, and just says like, "Look, we have a deadlock, cannot proceed." Does that make sense?
Yeah, sort of. Yeah.
All right, cool. So I need to block this. So I'll say from personal experience, deadlocks, like I just showed you, is like probably the top thing to debug in Go. So you have to be really careful. But there's some like common sense stuff you can do to avoid blocking. Um, Number one is I always put a buffer. Buffers don't always protect you, but it could like get you out of trouble. So okay, so here, let me get rid of that. All right, I got the fatal error. It's blocked forever, right? But if I put in a buffer here, it will not block. Oh, it does block. Sorry. It blocks because it's still reading before writing. If it was the other way, then I guess it would work. Um, Hold on. I'm just trying to think if I can write a quick example of why the buffer would save you from blocking. Here it doesn't because the read is first. If you ever have to do the write first and you block on a write, um, then this buffer will save you. All right, maybe I'll think about it for next time to make an example of blocking on a write. And in this case, we're blocking on a read, so the buffer does not help you. Okay. You guys have any questions so far? It's been about 1 hour. I can do one. Actually, no, I think I'll just wrap it up here today. After the channels thing, the next thing to cover is context, which is how you avoid blocking, is to use this thing in Go called context. But we don't have time to go over that today. So next time will be blocking on writes and context to manage channels and avoid blocking. Okay. So yeah, that's it for today.